Hello everyone. We are given versions of a product up to n number. There are good versions and bad versions. We have to find the first bad version. We do this by making an API call that determines if the version is good or bad. Once we find a bad version, all the rest of the versions will be bad. So we have to find this one bad version, which was the first one. Let's look at the constraints to get more information. There will be at least one version given to us, and there has to be at least one bad version. Because the versions are sorted in this manner, we can use binary search and reduce the number of calls to the API. Now this approach is simple. Let's look at the code to understand it. We have the left end as the minimum value of n, which is 1, and we have the right end as n. Next, we send API calls to the midpoint. If it was a bad version, we shift our right to the midpoint, and if it wasn't, we shift our left to the right of the midpoint. We will exit the loop only when the left value and the right value becomes equal, or the right value becomes less than the left value. In the end, we just return the value of the left, which was at the start of the bad request. Let's have a look at some of the outputs. For the time complexity, we can have 2 raised to 31 as the maximum value of n, approximately. If we keep dividing it by 2 every time till we reach that starting point, we can have maximum of 31 divisions, that is iterations, and so this will be log of 2 raised to 31, which is 31. So the time complexity is O of log n. The space complexity, on the other hand, is constant. We keep updating the two variables, and so it is constant, O of 1. That was it for the problem. What if the bad versions are not contiguous, but it could be any given version? Can we still apply the same approach? Please let me know in the comments below. There are links to similar problems in the description below. And as always, thank you for subscribing to my channel and liking my video. And I will see you next time.